Hi guys, let's find the integral of x times tan inverse of x. So the method we're going to use to solve this integral is going to be the integration by parts method. So let's get my cursor back and working, and here, so we're going to do integration by parts. Okay, so let's figure out our du and dv. So u in this case, since I comes first, that stands for inverse trig, we're going to let our u equal to tan inverse of x, okay? And the derivative of u, which is du, as we know, is going to be 1 over 1 plus x squared. Okay, the derivative of tan inverse of x is 1 plus 1 over x squared. The dv, on the other hand, that's going to be what's remaining. Okay, remember we put the dx. And then the x on this hand, the x, it's gonna be the dv. Okay, the integral of x is, as we know, x squared over 2. Okay, now let's do this integration by parts problem. So the integral of x tan inverse of x equals to tan inverse of x. Okay, so uv, right? I'm gonna write down uv minus the integral of v du. Remember, that's our integration by parts. So tan inverse of x times v, which is x squared over 2, minus x squared over 2 times the du, 1 plus x squared. Okay. Okay, so kind of like getting the half from there, half tan inverse, just to like factor it out, times x squared minus and getting the half. If you can see, we have x squared divided by 2. I'm going to take that out, and it's going to be x squared over 1 plus x squared. Now this is where things get kind of tricky when finding this integral. So I'm going to write down the first part of our problem, and I'll show you how this gets kind of tricky. So as you can see, we don't have a direct, you can do directly use u sub. Okay, if we do u sub u equals x squared, then that doesn't really cancel out that x squared. Okay, and we cannot even use 1 plus x squared. Again, that doesn't seem, if we take the derivative, that's we're gonna get 2x, and that doesn't seem to cancel out that x squared. We don't want that x squared to be canceled. Okay, so we could use a different method, this one that we don't really talk about, but it's completely legal to do. So let's see why I'm saying it's legal. So what we're gonna do is gonna add 1 on the top and subtract that 1. Okay, we're gonna kind of, let's see how we're playing with this. So add 1 on the top and subtract 1, and 1 plus x squared is gonna be on the bottom. Okay, we're adding 1 and subtracting 1. Okay, 1 plus 1 minus 1, that's gonna give us 0, right? That makes sense, right? So now, using some rules, what we're gonna do, let me write down the first problem. So what we're gonna do, we're gonna separate these two. Okay, you want to think of it like I'm gonna show you in a different color here, as a heart shape. You know, it's forming kind of like a heart over here. Okay, so when it forms that kind of heart, what we're gonna do is we're going to separate these two fractions. We're gonna put x squared plus 1, 1 plus x squared. We're going to write it like that. And we're going to put minus 1, 1 plus x squared. Again, this is completely legal to do. This will not, it's not something unmathematical, okay? So, writing down that x squared minus half. Okay, now 1 plus x squared, x plus 1 plus 1, that's the same thing. So we're just going to cross both of those out. Okay, so now we have 1 minus 1 plus x squared. Okay, now writing down our problem again, the first part. minus half. Okay, so now well, we could find the integral. This now we've gotten to the easy part now. Okay, so the integral of 1, that's just going to be x, right? That's going to be x. And then the integral of 1 over x squared, as you recall, the integral of 1 over 1 plus x squared, I'm going to write this, is equal to the tan inverse of x, okay? So this is going to be tan inverse of x plus c, okay? Now, as you can see, what we did here by kind of like making our way through, we kind of got from here to here, okay? Which would otherwise be more difficult if we didn't do the plus, minus, +1 and -1 on top, okay? So now we've kind of gotten to our answer. What we could do if we wanted to, we could like distribute this half, or we could like factor out the half, right? 10 minus we could do minus tan inverse of x, right, plus c. We could just put the plus c outside since that's just a constant, right? And then if we wanted to even simplify that further, we could do tan inverse of x times x squared minus x plus tan inverse of x. Okay, and that's it. That's our final answer. This could be our final answer. Right. If you did like the problem, please like, share, and subscribe to my channel. Thank you for supporting, and let me know if you have any questions in the comments. Thank you.